topic that says graphing inequalities and systems of inequalities. So we're going to be graphing an inequality on a coordinate plane. So if you recall, earlier in the year, we graphed on a number line, and based on the inequality symbol, we either had a closed dot or open dot, and we shaded to the right or shaded to the left. Well, when you graph on a coordinate plane, okay, that means using the 4 quadrants, I'm going to tell you how to determine if we write a solid line or a dashed line. So let's just make a little key at the top. So if you have a less than or greater than symbol, then you're going to make a dashed line. And if it has the equal sign under it, like this, then you make a solid line. So you're just not going to automatically draw a solid line this time, because what we've been doing when we've been graphing equations, because it did have an equal sign, it was solid. All of them were solid, because it was like y equals 3x plus 5. Okay, since they're inequality symbols, it's not going to automatically be a solid line unless there's an equal sign under it. So basically, if you see a solid line under the inequality symbol, then you make a solid line. If not, it's going to be a dashed line. Then there's also some shading that goes along with this. Okay, so there's another key for shading. So I'll put that in right in here. So for the shading part, if it's greater or greater equal, then you're going to be shading above the line, right? And if it's less or less equal, you shade below the line. So, but what if it's a vertical line? Okay, so if it's a vertical line, okay, let's put vertical. I may have to make my box a little bigger. So if it's a vertical line and it's greater or greater equal, then you shade to the right. And then obviously, if it's less or less equal, you shade to the left. All right, so that's your little key to use for the shading part of it. All right, so first we're going to start off just graphing 1 on a coordinate plane. And then notice when we get to the next page, just like a system, we'll be graphing 2 on the same coordinate plane. Okay. All right, so let's start off with this first problem, and everyone knows how to graph. We start with +1. And then our slope is -1/4. So I'm going to go up 1 and then to the left 4. And there's by the dot. And then I'm going to go also down 1 and to the right 4. Right. Now I have to pay attention. I can't just automatically draw a solid line. And actually, since there's no solid line under the inequality symbol, I make a dashed line. That means you don't connect it. Okay, it's just like dashes. All right. So once you do your dashed line, now we have to do the shading. Since it's less than says you shade below the line. So then we just shade below the line. Okay. And that's it. Okay. So the good thing is you already know how to graph. The only thing you have to pay close attention to is whether it's a solid or dashed line and whether you shade above or below. All right. So let's look at number 2. So we're going to start at +3, which is here. And since I can't go up 7 and to the right, I'm going to do a double negative. So I'm going to go down 7. and then go to the left 4. All right. And this is also going to be a dashed line. And this is also less than, so I shade below. So basically, let me tell you what the shading represents. So when we're doing this shading and we're shading below the line, we're saying any coordinate that is in this shaded region would be a solution to this problem. Okay, so any of these points in here, if I took an ordered pair like, let's say 0, 0. If I put 0 in for y and 0 in for x, I'm going to end up with 0 is less than 1. That is a true statement. Okay, so they're basically saying any point in the shaded part would be a solution to the inequality. Since it's a dashed line, any points lying on the dashed line would not be a solution. Okay, if it's solid, it would be a solution to the inequality. All right, so points on a dashed line are not solutions. All right, let's go down to this one here. So we're going to start at -2, and then I'm going to go up 7, and then over 5. Okay. And actually, let's make this, let's change this problem and put an equal sign under it so we can practice using a solid line. So that means since I've changed it, this would be a solid line. And since it's greater than, we would shade above the line. So this represents any point directly on this solid line would also be a solution, including what's in the shaded region. Okay. All right, let's do one more. All right, so let's start at +3. And then I'm going to go down 1 and then to the right 2. And we'll keep this one as a dashed line. Okay, and since this is also greater, you shade above the line. Okay, any questions so far? Okay, pretty basic, just graphing and shading and paying attention to if it's solid or dashed. All right, let's move on to the next page. Okay. And now this is where you might even decide to use like a pen and a pencil or 2 different colors, because what's going to happen is when we graph both, the solution area is only where they intersect, the 2 shading parts intersect. So you're going to see when we do this, we're going to have to make it very apparent that this is the solution, okay, where the 2 overlap one another. So if you are using a pencil, then you'll have to make sure that part is a lot darker. And if you use 2 different colors, it'll be very easy to see where they overlap, because you will be able to see the 2 different colors. So that's why I said sometimes it's nice to either use a pen and a pencil or 2 different color pencils. Okay, so for the first one, we are going to start at -2, and then I'm going to go up 1 to the right 2, up 1 to the right 2. So I'm graphing this first one right here. And since it just has a less than symbol, I am going to do a dashed line. And it is less than, so we shade below. Okay. So I'm going to use a different color for the second one. I'm going to start at +3. And then I'm going to go down 2 over to the right 1, down 2 over to the right 1. And this one is a solid line, okay, because it has the equal sign under it. This is greater than, so pay attention to what I'm going to do before you start shading. This is greater than, so that means I'm shading right here, and see how you can see where the two colors are? That is the solution. I don't need to actually shade in this area because I can tell that's not where the two colors are going to overlap. So there's no need to even shade up there. I mean, you can do that, but I already know that's not going to be part of the solution area. Okay, so I'm not just going to do it, to do it. You can, again, but it just makes your problem look a lot neater when you can actually just focus on where the overlapping is. Now, if you're using just a pencil, you would actually have to shade this area darker than the rest of your pencil so you can tell where the solution area is. Okay, so that's why I said if you use two colors, you wouldn't have to shade that part darker, but that has to be darker if you're using a pencil. Okay, number 6, let's do that one. So we're going to start at -1. Okay, then I'm going to go down 2 to the right 1 and up 2 to the left 1. And this is a dashed line. This is greater than, so that's above the line. And sometimes students don't even do the shading until they graph both, and they can kind of see where they're going to overlap and only do that piece. Okay, and you can definitely do that as well. Start at +2. Then I'm going to go down 1 to the right 2, up 1 to the left 2. And this one is a solid line. Okay, this is also greater than. So technically, it's only going to be overlapping in this area up here. Okay. All right, so I'm going to give you an opportunity to do these two here. And then I'm going to actually do another one on the next page, which is your classwork, because on the next page, they're not already in slope-intercept form for you. So we'll do one where, you actually have to solve for y. All right, so I'll give you a couple of minutes to do questions 7 and 8. All right, so let's go to the next page, page 20, which is where some of your classwork will come from. But I want to do question number 11 with you. Okay, so if everybody would go to page 20, question 11. So keep in mind, guys, when you only see one variable in the problem, there's not an x and a y, that means it's either a horizontal line or a vertical line. So when it's x and a number, it's a vertical line. When it's y and a number, it's a horizontal line. So this is a vertical line, so we're going to go on the x-axis to 3 and make a vertical line. Now, will this vertical line be a dashed line or a solid line? Dashed. Okay, so let's make a dashed line. Okay. And this is less than, so we shade to the left of it. We don't have above and below for a vertical line. All right. So now the second one and all the ones up here are not in slope-intercept form. So we're going to have to take this question and we're going to have to solve this for y. So we're going to subtract the x to the other side. Okay, you guys know how to isolate a variable. And this will give us -3y is less than -x minus 6. Always put your x term first. Okay, what happens when you divide by a negative? Remember when we did inequalities? Right, you have to reverse the symbol. And a negative divided by a negative, now that becomes a positive 1/3 x. Because remember, there's like an invisible 1 here. And a negative divided by a negative makes that a positive 2. So this is what we're graphing. Y is greater than 1/3 x plus 2. So I'm going to start at positive 2. All right. And then we're going to go up 1/3. Okay. And this is a dashed line as well. And my symbol was greater than, so the shading is up here. So the solution would be where you see the two colors. And that's it. All right. Any questions on that? All right, so going back to the agenda. Okay, so we have already finished, I believe, 18 and 19. Is that right? So now you're going to, and this should be a E, complete pages 20 and 21 for classwork. And then your homework is what you have listed on your calendar.